All right, but that's not the only problem that needs to be solved ultimately. We also need to make the internet user-friendly, if you will. And it would be really tedious if you had to visit websites, for instance, by way of their IP addresses, right? 1.2.3.4 is pretty memorable, but there's like 4 billion other possible addresses available. And it would be super tedious to remember those. It would be bad marketing to advertise those. In fact, most of you probably don't even know the phone numbers of your closest friends and family members anymore because you instead store them in your contacts or in your address book, associating with numbers that are completely opaque with actual names or strings, if you will. The same goes for the internet too. Even though every computer does have and must have a unique IP address numerically. Why? Well, routers are computers. Computers just crunch numbers very readily, but we humans work better with strings of text. We need some system for converting user-friendly strings like harvard.edu or yale.edu or google.com to the underlying IP addresses. And that's where the next acronym comes in today, which is DNS, Domain Name System. So this is just another technology that's been in use for some time now. And it's a collection of servers on the internet whose purpose in life is to convert domain names to IP addresses, and maybe vice versa as well. So let me stipulate for today's purposes, there are some root DNS servers in the world that, long story short, know about all of the .coms, all of the .edus, all of the all of the other top-level domains around the world, as well as in the US. And then there are some smaller DNS servers owned by companies, owned by universities, and even in your apartments or homes, most likely. Indeed, if you have a home router plugged into the wall somewhere, that's not only routing your data in and out of your apartment or home or dorm room, it's also typically serving as a local, therefore faster DNS server, a cache, if you will. It's sort of locally saving your most frequently accessed websites and their IP addresses just to avoid bothering the bigger, more expensive, busier servers all day long. So there's DNS servers all over. If you poke around your settings in Windows or Mac OS or Android or iOS, you'll see mention of DNS, and you'll probably see the IP addresses of the servers whose purpose in life is to do this conversion for you. But this is a requisite feature if we just want the internet to be user-friendly and allow us to use words instead of numbers alone. What's inside of these DNS servers? You know, it's essentially a spreadsheet, or if we can say it more geekily, it's essentially like a hash table of some sort, which it has keys and values. Like the key is the domain name, harvard.edu, yale.edu, google.com, and the value is the corresponding IP address, or in many cases, IP addresses, plural, of the corresponding servers. So here already, even though I've drawn it fairly abstractly, like you would on a chalkboard, it's really probably implemented as some kind of table, maybe a hash table, maybe a database table, maybe SQL or something like that, or maybe it's even just a linked list or an array. We just have to somehow enable this computer to convert one to the other. Now, just to be super precise, DNS servers actually convert what are called fully qualified domain names, which is generally not just harvard.edu, but more verbosely www.harvard.edu and www.google.com. So the whole thing that you would see as a substring of the URL. So that's what DNS does, and that's what your university, your company, your home router are doing for you. Let me pause here to see if there are any questions. This, too, is just a technology now we'll take for granted, just works. Questions at all? No. All right, so let's now transition among our protocols really to the last for today, which will set the stage for actually solving problems with these and writing some code ultimately. HTTP. This is something that you see or hear all day long, even though you rarely have to bother typing it anymore. Odds are if you go to harvard.edu, yale.edu, google.com, you don't bother typing HTTP, let alone HTTPS manually anymore. Why? Because your browser auto-completes, that kind of thing, just to make life easier. But it is officially at the beginning of every URL you visit, either HTTP or the more secure HTTPS, whenever you're using your browser to access some website. So HTTP stands for Hypertext Transfer protocol. And it's easily one of the most popular, dare say one of the most powerful features of the internet nowadays. But the mental model to have here is that HTTP, or the web more generally, is kind of a service that runs on top of the internet. And maybe Zoom or Microsoft Teams is another service that runs on top of the internet. And iMessage and technologies like it is another service that runs on top of the internet. So the internet is really like the lower level plumbing, the TCP/IP stuff, the DNS stuff that just gets data from point A to point B. But now, and we're in a software development class ultimately here in CS50, HTTP is the application level protocol. It's sort of what programmers use, what companies use, what developers use ultimately to use the underlying plumbing, to build interesting and powerful things. So what does this mean when it comes to accessing services via HTTP or the more secure HTTPS? Well, here is a representative URL. Even though you might not type the whole thing, if you poke around your address bar, this is what's up there. With that said, a lot of browsers nowadays are kind of simplifying, if not dumbing down, what you see with your human eyes, just to shorten the strings, especially on mobile devices. But almost always, if you click the URL or highlight it, then you see the whole thing. But on many browsers, you might only ever see example.com, but all of this information is there. It's just getting more and more hidden just for user interface's sake. Well, it turns out when you visit a URL, by default, especially if you type nothing after the .com in this case, you're technically implicitly adding a single slash. So a single slash denotes the root of the server. That is the default page or folder in the server. And the slash, whether or not you type it or not, is implicitly going to be there. And that just means give me the default. Whatever's at www.example.com, give me that page or that folder. But URLs can be longer than this. And more generally, there can be a path, so to speak. And this is a term of art. A path is some sequence of folder and or file names after a URL like this. And so you might see more specifically that a URL contains a very specific file. This isn't as common nowadays anymore, though we will begin today by using this technique. But if there is a file called literally file.html or something else on the server, that file is going to be what this URL pulls up on the computer. Meanwhile, you might have /folder/, which just means show me whatever's inside of this folder. Or you might have more verbosely /folder/file.html, which will show you that file in that folder. And meanwhile, just to give some other terms of art, this is the so-called fully qualified domain name. And again, these vocab words don't matter all that much, but you'll hear or see them over time. We generally, colloquially, just refer to this as the domain name, which is a little less precise, but gets the job done, certainly in conversation. And this part here, I described briefly earlier. What's the name for this suffix at the very end of the fully qualified domain name? Top level domain, or TLD. And this is just some form of categorization of the URLs. Now, the internet got its start within the United States, and a lot of the first websites, of course, came from the US. And so, for better or for worse, a sort of stake was planted in the ground. So generally, .com indicated, at least early on, that it was some kind of commercial enterprise, a business that owned a domain name. .edu is an educational institution. .net was some kind of network. .gov was the US government. Now, there are also country code TLDs, CCTLDs, like .uk or .jp. Every country in the world has its own two-letter TLD that might very well be restricted to only servers or companies or people in that country. Many of them can be used by anyone. You've used a lot of URLs in this class ending in CS50.io. That doesn't mean input, output. It actually is a TLD from another country that lets anyone on the internet pay for and on an annual basis using that domain. .tv, for instance, you might see in some cases, like twitch.tv and the like. That, too, is owned by another country that allows others in the English-speaking world, in this case, to use it as though it connotes TV. But those are just different types of TLDs that roughly categorize where the domain lives. But it doesn't necessarily mean it's commercial anymore. It doesn't necessarily mean it's a network anymore. For the most part, there are hundreds of TLDs now, for better or for worse, most of which are less common than these big ones. But most anyone can buy most of them, with just some restrictions on things like .edu and .gov that are still very much regulated. This, meanwhile, is what we might call the host name, www. It's obviously a super common convention. Like almost every website uses www as its host name. But that's a human convention. It's not a requirement. And indeed, some websites websites don't even bother having a host name. They just use their domain to advertise their website. This now is going to be the scheme or the protocol. And this is just going to indicate via what protocol the computer, your Mac, your PC, your phone, should use when accessing content at that address. Because indeed, there are other protocols you can use. But for the most part, we'll only focus on HTTP or equivalently HTTPS. All right. Any questions now on those just definitions, building blocks of URLs, just so we all sort of share a common vocabulary? Any questions at all? Yeah? Sure, we'll come back to this actually later today. There's a technical term known as localhost, which is a generic name for your computer, your Mac, your PC, your phone, especially when you're doing software development. And by convention, your own computer has not only whatever IP address you get from your university or your internet service provider, it also has a reflexive IP address, one that just always refers to itself, which is 127.0.0.1. And that's just a human convention. Humans decided that shall refer always to your computer. And it's actually going to be useful today and onward because we can use that when doing development on our own computers ultimately. Other questions on URLs, IP, DNS, or any of these building blocks? All right. So what do we mean by HTTP being a protocol? When I extended my hand earlier as a human handshake, you know, a typical human in healthy times would know to respond in turn. Well, how does Brian's computer know to respond to Phyllis's envelope, whatever message is therein? Well, assuming that Brian is indeed still a web server in the story, and Phyllis was trying to upload a cat or maybe download a cat from Brian's web server, inside of Phyllis's envelope would have been a message, literally in text, and it's English for the most part, and it would contain at the beginning of that message literally one of these English verbs, either get, which means just that, get me the home page, get me a picture of a cat, get me a picture of a dog or a video or anything else, or post, which often means post, that is, upload a picture of a cat or a dog or something else to the server instead. That's not strictly the only use cases for these, but you can generally think them as one is just getting information and the other is posting from the client, from Phyllis to the server, in this case, Brian. So those are the two keywords that we might see. And why is this useful? Well, it turns out we can start to see in our own Mac or PC some of these very same messages. For instance, if Phyllis were visiting, not Brian's, but example.com, that web server, inside of her metaphorical envelope, there would be a textual message that literally starts with get slash, then the word HTTP, then the version she's using. 1.1 is very common. 2 and 3 are becoming more common. But HTTP generally looks like this. The next line of text in her envelope would probably say host : then literally the fully qualified domain name of the server she's accessing, just in case, and this happens super commonly, especially on small websites, if one server is hosting multiple domain names, multiple websites, this just distinguishes which one she actually wants. And then there's usually a whole bunch of other lines of text as well. So where can you actually see this? Well, let me actually go ahead and do this. Give me just a moment, and I'm going to open up on my computer here an empty Chrome window in incognito mode. Generally speaking, incognito mode or private mode is used when you don't want there to be left remnants of what websites you visited. And it has the effect for software developers of just forgetting any things you might have tried already within your browser, including things called cookies. More on those another time. Your autocomplete history and the like. So for development purposes, incognito mode is especially helpful because it's sort of like starting with a clean slate every time you open a new private or incognito mode. So there's not going to be like any remnants of previous testing or code that you've been playing with. And I'm going to go ahead and do this.